In pretty much any logic class or any critical reasoning class, you're likely to learn that there are different types of arguments. The two major types that are usually covered in these classes are deductive arguments and inductive arguments. So let's spend some time talking about those. I think it's best to start with deductive arguments, as these will normally be the focus of most formal logic courses, and I think critical reasoning courses have a tendency of spending a fair amount of time on these. So a deductive argument is just an argument that aims to provide a guarantee for its conclusion, right? So if a deductive argument is successful, then you can know that its conclusion is true with certainty. Now, let's consider an example just so that we can see that in action. And it's a fairly straightforward, easy example. I'll usually try to avoid anything too complicated. So here it is. Premise 1, all human beings are mortal. Premise 2, I am a human being. Therefore, conclusion, I am mortal. Notice this is an argument that is deductive and successful, right? So the premises are both very clearly true, right? All human beings are indeed mortal, and I really am a human being. And the conclusion absolutely follows from those. It's not a matter of probability or likelihood. It's just if those premises are true, then you know for a fact that the conclusion must be true. Now, there's not much else to be said for or about deduction except for this. Success is the aim. If a deductive argument fails to guarantee its conclusion, that doesn't make it no longer a deductive argument. It just means that it was an unsuccessful deductive argument, right? So all that matters is that the argument be attempting to offer a guarantee for its conclusion, and that's something that you can figure out just by looking at the argument's form, which I will have future videos on so that we can figure out how to do that. Now, the other type of argument is inductive arguments. And these are the types of arguments that aim at providing a high probability that their conclusion is true. So they're not aiming to offer a guarantee. So if an inductive argument is successful, then you're justified in believing that the conclusion is true, but there is the possibility that all of the premises are true and the argument is good and all that, and that the conclusion is still false. So this is the kind of reasoning that's oftentimes found in the sciences, right? And I'll give you a couple of examples, or at least types of examples, right? So here's one way that science very often operates. You go from a set of samples, right? Prior observations. So I don't know, I grab the pen and I, release it and it falls down, and then I grab the pen and I release it and it falls down, and then I grab the pen and I release it and it falls down. I do that another 800 times, right? And I've gathered a lot of evidence. And I go from that evidence to conclude the next time that I drop the pen, it will fall down. Now, could I be wrong? Oh, yeah, I mean, it's possible, right? But it's really, really unlikely. All of this previous evidence gives me great reason to believe that the next time that I let go of the pen, it's going to fall down. Now, maybe I'll leave the room and someone will pull a practical joke or something, I don't know, install a magnet in the pen and make it go upwards, right? But that's just an extremely unlikely set of circumstances. Nonetheless, what we are left with is just a really strong probability, not a guarantee. Another type of inductive argument that's often used in the sciences is where you go from that set of samples to a general claim, right? So rather than just talking about the next sample, you then go ahead and say something that's supposed to apply everywhere. So for instance, physics is in the business of doing this, right? A lot of observations of objects being affected by gravity or, what have you, leads to a theory of gravity where you say, okay, so this stuff must happen everywhere, everywhen, all the time. And there are interesting problems that come up with induction that I'm hoping to post videos about in the future. But anyway, the point is, any inductive argument is aiming to provide a high probability for its conclusion, which means any successful inductive argument will give you very good reason for believing that its conclusion is true. And in fact, a lot of our reasoning is inductive. Whatever Sherlock Holmes may have said, most of his arguments were not deductions, right? Most of his arguments were inductions. There was the possibility that he was wrong. Now, in an intro to philosophy class, in an introduction to logic course or an introduction to a critical reasoning course, oftentimes deduction is the main focus. This is especially the case in formal logic, just because it's much easier to teach students a formal system that's deductive. right? This will give you a solid foundation, and then you can move on to taking more difficult courses, because it turns out that inductive reasoning can be a bit harder to formalize, though I'm hoping that I'll also post videos in the future about inductive systems, formal inductive systems. Now, before I finish off today's video, I do want to say these are not the only two types of arguments that exist, right? So there are others. For instance, a third type of argument is what's known as abduction, which is a weird word. It's sometimes better known as inference to the best explanation. And I won't say much about it here. Suffice it to say that this is a style of argument where you pit competing theories against each other. And what makes one theory better than another is just how virtuous it is, where what that means is just, for instance, that the theory is simpler or has more explanatory power or that kind of stuff, where that doesn't really neatly fit into the mold of deduction versus induction. And someday I'll post a video about that as well. But in any case, that's enough for today. So stick around and I'll see you next time.